So yesterday I did an introduction to operators in OSM. In today's session, I will be covering CNFs that are containerized network functions and Juju bundles. So we will be focusing only in Kubernetes charms. So in this session, I'm starting with an overview of the performance monitor scenario that was presented yesterday. Then I will explain some basic concepts about Kubernetes operators. Once we have a clear vision of the basics of Kubernetes operators, I will give an overview on what a squid is and the actions that implements the charm that we are basically going to deploy. And finally, I will show the important part of the VNFD, how to onboard the packages to OSM, deployment, execute some actions, and the validation of those actions, and check that those were actually well executed. So let's start with the performance monitor overview. So what we will do in this session and the following one is the whole thing, okay? So after today, okay, we will finish all this. But in today's session, I will be focusing only in one part. So, but just to have a clear vision of everything that we will cover, the performance monitor scenario that we proposed had three charms: Prometheus, Grafana, and Squid. So with Prometheus, what we do is we get metrics from the node exporter, okay, that is in a Squid, and then Grafana can show those metrics in a very pretty way, let's say. But in this session, we are only covering the Squid charm. And then in the next session of Juju relations, I will be covering the relation part between Squid, the Prometheus, and adding the node exporter and all that. But for today, for this session, just the Squid. So now the basics of operators. As a recap from yesterday, charms are universal operators, as we saw, and they let us operate physical, virtual, and containerized network functions. And we said that there are two important parts: the operator and the application. The operator is the code that contains all the operations for the application, and is the software that drives another software. And then the application is the actual workload. So in other words, the operator is software that drives software that is the application. Particularly in Kubernetes, the operators run in a pod. Okay, I forgot to say something, and is that you can ask me questions both in the chat in GoToMeeting, and also I opened a thread in Slack. You can ask me questions there if you have any, or just interrupt me while I'm presenting. Okay, so to understand what a pod is, pods are the smallest deployable units of computing that you can create and manage in Kubernetes. So a pod is a group of one or more containers with shared storage and network resources, and basically all the containers of one pod are always co-located and co-scheduled in the same Kubernetes worker. And this means that we can have one pod with multiple containers, and we'll see that in the next session when we are going to have one pod with both the script and node exporter. So in the example that we are deploying in this session, we will find two pods. One of the pods is the operator pod, where the charm code is, and another one is the application or workload pod with the application itself. So in Kubernetes, Kubernetes operators are deployed in OSM using Juju bundle. So I'm going to explain very briefly what the Juju bundle is. It's a really simple concept that you will understand right away. So Juju bundles are basically collections of charms. They represent not only one application, but an entire model, an entire stack of charms. And it's basically a YAML. As you can see here on the right side, this is basically YAML. And here in this YAML, we specify the charms that we have, that in this case, MariaDB and MediaWiki, okay, with the URL to the charms and so on. Then the config. So in the case of MediaWiki, we have an option that is debug, and we can enable the debug of that one. So that's the config, and then the relations at the bottom. That basically we can define here that there's a relation between MariaDB and MediaWiki. So it's as simple as that. And this is what is used basically in OSM to deploy a set of Kubernetes charms. So now the script overview. So just to have, for those that are not familiar with the script, as I said before, we will onboard the script using Kubernetes charms. So the workload will be deployed in a Kubernetes cluster as a pod. And a script is basically a web proxy that will act as a firewall and cache. And it implements two actions, add URL and delete URL. And basically, when we add a URL, we will see that we can actually contact the URL through the proxy with no problem, and if we delete it, then we won't be able to access it through the HTTP proxy. And by default, a script will deny all connections to everything, so it will be easy to test. Okay, now the descriptors and the onboarding to OSM. So in the DNFD, there's a part that also Gerardo showed before, and is the KDU part. In the KDU, we can define both Helm charts or Juju bundles. So in this case, as we are going to deploy a Juju bundle, we have the KDU, and this is an array of KDUs. In our case, we only have one, and the name I give it to it is script metrics KDU, and the Juju bundle is bundle.yaml, which is a local YAML, but also I could reference a bundle in CharmHub, that is the store, let's say, with all the charms and bundles and so on. Okay, so this Juju bundle, or this bundle.yaml, is inside the Juju bundles folder in the descriptor. And there we can see something like this, okay, which is a bundle with just one application, which is pointing to the script operator, okay, the script charm. Okay. Now, adding the two operations. So, as I said yesterday, but I repeated it today, is that charms is the best way of doing the day 1 and day 2 configuration, because basically it allows you to operate the workload not only at instantiation time, but also if you want to operate on day 2, day 4, day whatever day, you can actually make operations on it as you want. So there's one part in the BNFD that is, well, it's until here, the day 1, 2, okay? And here, when we put the config primitives, then we have an array of primitives that we expose, which is, in this case, add URL, which has 2 parameters, application name, that is the application name of the bundle, okay? Because we can have many applications here, so we need to specify this action to which charm is associated. So yeah, so basically, yeah, the application name and then the URL. Okay, and then similarly, we have the delete URL action, which has the same parameters. Okay, so now I'm going to first show the commands, but I will please ask that you don't execute anything yet. So I will show the commands to explain them and so on. We have time enough, so don't go too fast. Okay, then I will execute it. You will see it, so how it works and so on. And then while I'm executing the commands, I will paste those commands in the path. Okay, that I will paste the link here in the chat. So I will be pasting the commands there, and then you can execute them and play with it. Okay. So to onboard it in OSM, well, I have created or put the packages needed in this folder. Okay, in the Hackfest folder. So you just need to copy that to your local home directory, okay, and cd there, and then upload the packages using these 2 commands. Really simple. Then for the deployment, I put this command that is basically we do an ns-create, okay, we give it the name of a web proxy. The network service descriptor name is this one. Then the Vim account is the same as your OSM user, so this command should work for all of you. And then as part of the configuration, we have the VLD, okay, the virtual link descriptor with only one item, that is the management network, which Vim network name is OSM-MR. Okay, this is what well, I think this is not really needed. I think this could be skipped because I'm not using this for anything. But yeah, that can be removed. Okay, then we will watch the network service status, okay, and we will wait until we see it as ready, and then we can execute actions. And the action we will execute is we will add a URL, and the URL will be osm.etsy.org. And then after that, we will validate that action, okay, executing the following commands. We will get the load balancer IP assigned to the script proxy, so we can set it as our HTTPS proxy, and then do a curl to google.com and to OSM-MR. And we'll see that the first one will fail because we haven't enabled it yet, and the second one will pass because we enabled it. So, okay. Yeah, so there's a question, management net is the same name as in OpenStack. So yeah, here I haven't, so this part is because if in the descriptor I have the management net reference to some network, I can override the Vim network name because I could have one descriptor that I deploy in my OpenStack, and you deploy the same descriptor in your OpenStack. And maybe my Vim network name for management is OSMX, but for you is another has another name. So a great thing of OSM is that you can parameterize your network service instances so that we can use the same descriptor in different contexts, giving different parameters, and it will work very well. Okay, so now give me a second because I'm going to stop sharing and I will share my terminal. Okay, can you see my screen? Is it big enough?
Yes, that is plenty big. You could make it a little smaller if you desire.
Oh.
That still looks very clear.
Okay, perfect. So, first of all, okay, I'm going to copy to my, okay, I think I have already copied, yeah, it's there. Okay, so in my case, I have already copied the package, okay, but okay, just for showing it, I'm going to take this, copy there. Okay, and I'm pasting the commands in the path, okay? Here, okay, I already sent the link of the path. In the bottom of the path, you can find them, okay? Then I'm going to change my directory to be there, okay? And I'm going to upload the packages. All these commands, you can execute them if you want. Okay, so now I have uploaded my BNFD, and now I am uploading my network service. Okay. Okay, is that clear? Let me paste this to. Okay, if you are deploying that, or if you are uploading those, you can mark a column in the spreadsheet. So I'm going to create a column there, HD2.5, upload packages. So you can put a yes once you upload those. Okay, I see people are progressing. Okay, perfect. So now what I'm going to do is I'm going to do the ns create. And for that, I will paste the command, okay, OSM ns create, and I can do a watch of OSM-NS list. Yeah, I have uploaded first the VNF and then the network service descriptors. This is the reason why I did it in this order. Is because the VNF or the network service reference always one or many VNFs, and it can make virtual links between those and do the connections, necessary connections between them, and so on. So the smallest unit is VNF, and then a network service will contain the DNS. Okay, yeah, that error that user is having, that conflict is because you have uploaded first the network service descriptor before uploading the DNF descriptor. Yeah. Okay, so I'm going to do a watch of the web proxy. We'll do it a bit smaller. Okay. Okay. If you see, I have that service ready. Okay. I'm going to paste the command. Okay. So now I'm going to wait a bit more for the network services to be in ready state. Okay, I'm going to go now and execute a day 2 primitive. So the primitive that I'm going to execute will add OSM-MR as the as a load domain, let's say, so we can access that URL through the HTTP through the web proxy. Okay. Someone is changing the commands in the pad. Please do not change those because if you change that, then it will fail for the rest. So OSM user is a variable that should be in all of the users, and it will have the right value for your user. Okay. 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 So as I was saying, the action I just executed will add this domain as a load in the web proxy, and I can list. I can do OSM-NS list, and I can do OSM-NS operation list, like so, and enter the name of the network service instance, and I will see the list of actions that have been executed. So the first one is just the instantiation, but the second one is the day 2 action I executed. So now, now what I'm going to do is I'm going to get the squid proxy IP, okay, and so that I can use that as my HTTPS proxy. Okay. For that, we can do several things. So, well, first of all, what we can do is we can do an OSM BNF list, filtering filtering. This is outdated. Sorry. Filtering by the. Oh no, it was okay. Sorry, forget that. Okay, so we get the DNF list, okay, and we see only one DNF, and we can do a DNF show of the ID of that DNF. Okay, executing that, we will see several things. We will see the Juju bundle, the services, okay, that were created in Kubernetes. This week, well, I found one little bug that I will fix, but right now, so here in the services, we should be able to see the load balancer IP of the squid, but we are not able to see that because of that little bug. So I'm going to try and fix that for Friday's session. I will do my best to do so, but there's other way of getting the load balancer IP, so we are good for this session. So for this session, what we need to do is we need to get the ID of the network service, okay, which is this long string here in my case. So doing OSM-NS list, we see the ID, okay, and then we execute the following command. We execute this command, kubectl-n, and this is the namespace is the same as the network service instance ID, and then get SVC, that this will get us a list of services in that namespace in the Kubernetes. So if I do so, I will see that I have the model operator, the squid operator, okay, and then a squid here, load balancer, and the external IP is this one, okay. Each one of you will have a different IP, okay. So now what we are going to do is the following. I'm going to use the squid IP here, squid IP. Okay, so I'm setting the HTTPS proxy to this, and then doing a curl to google.com. This should fail with a 403 command. Okay, this means that the HTTP proxy is not letting us pass through it to that URL, is denying the access. Okay, but if we do the same thing for OSM-MR, we get content. So this means that it is letting us pass through the proxy. Okay. For those of you who have already finished the actions and everything, I'm going. You can execute this command. So OSM-NS delete web proxy. Okay, and wait there until you see the web proxy disappear. Okay, wait until the NS has gone. Okay, once it's not there, you will need to remove the descriptors, and I will paste the commands soon when it finishes. Okay, this usually takes a bit because we need, so OSM is making sure that we have removed all the resources that we created in the Kubernetes cluster. So it's deleting the namespace that was created, the pods, everything, and this usually takes a bit of time to clean that in an ordered way. Okay, we haven't executed the delete URL. Maybe for next session. For next session, we will execute it. I I totally forgot that. But don't worry. Next session we can do it. Okay, in which scenarios we can have proxy charms in KNFs, and is there any difference in executing proxy charms and native charms in KNF? Okay, so when we talk about KNF, we talk about native charms in Kubernetes. Why? Because the charm, let me open, or let me share really quickly one thing, because this can be explained better here. Okay, so we have two things, or so you are asking for two things. One is KNFs. Okay. For KNFs, basically, what we are deploying are KDUs that are applications, so Kubernetes applications. So in that case, we have the charm, okay, the charm that is the operator, okay, and this charm will deploy let's say the pod, the workload pod in Kubernetes. Okay, but all this is handled by the charm. So the charm manages the full life cycle of the pod. But then the other thing is Kubernetes, so Kate's proxy charms. So in general, in proxy charms, what we do is we have a charm, okay, that is the operator, and we have the VNF. Okay, and this charm can live, so this charm can live in two places, but one of them is Kubernetes, okay? But the purpose of this charm is just an operator. This charm won't have one workload associated to it in Kubernetes, because it will point to another thing that in this case is a DNF. It can be whatever, a DNF, whatever. But this charm won't deploy the workload and will manage the whole life cycle from inside, okay, of this VNF. The VNF is one thing that could be, let's say, deployed by OSM, and the charm will execute actions against that, but it's outside of that context. Okay, I don't know if that's clear. I will start using more of this. I think it's good for some explanations. Okay, so let's go back. I see that there's no NS instance, so I'm going to do NS delete. Okay, I'm copying that in the path, and I'm doing bnfd delete. Okay, so once you finish that and you have deleted the bnfd, you can go ahead and execute and put the yes in the last column, that is environment cleaned. Okay, well, most of you have already validated the action, so really happy to see these results. Congrats, everyone. Okay, it's important that all of you have cleaned the environment, because in the next session we are going to deploy this again, but doing a few changes. And so, okay, sorry, was there any question?
I see a question in the chat that I wasn't quite sure if had been explained properly. So what makes a Kubernetes charm a native charm versus a proxy charm? The question is, charms managing the pods are native charms because they're located inside the K8s cluster?
It's not because they are located in the K8s cluster, because Kubernetes proxy charms are located in a K8s cluster too, but they are managing something that is outside of that K8s cluster. It's managing a VNF, for example. So in the case, so you remember yesterday's session, right? In which you had a proxy charm that was managing a PNF. Okay, that proxy charm was created in LXD, but you can create that instead of in LXD in Kubernetes. And what that will do is basically it will you will have one operator pod, but you won't have let's say a workload pod associated to that operator in Kubernetes. Okay, there's also another question. When to use Helm or Juju for CNFs? It depends. So if you are doing, so if you want to deploy something and there's already a Helm chart and you just want it the way it is, okay, and just going to go ahead and deploy it, and that's enough for you, you might as well go and use Helm with no problem, okay? But I would strongly recommend Juju when the workload that you are deploying, so that you want to add day 2 operations to it, you want to integrate that with other charms and things like that. So Juju is very, very powerful for that. And this Friday, I will do one session that it will be a 2-hour session, in which I will start from a Docker file doing, so I will create a Docker file, create a Docker image from there, and build a charm from scratch and add actions to it and things like that. And yeah, so there you will see some of the benefits, and also if you are creating something from scratch and you want to take advantage of customized day 2 operations, and you want to also handle scaling, handle relations and things like that, I strongly recommend to learn how to do a charm properly and achieve those things. And obviously, as I always say in all the Hackfest, I'm happy to help. You can ping me in Slack whenever you want, and if you need help or guidance, I am open to help you through the process of learning and things like that.